Good afternoon, everyone. Welcome to day 3 of the yearly COSI Science Festival. Of course, because of the pandemic, we're doing all things digital. We're really happy. It's been an incredible 3 days. Tomorrow's our last day, so make sure you check out as many more festivities and episodes and shows that you can. They're all for free. They're fantastic. They'll really get your weight up, as we like to say, around all things science, technology, engineering, and math. But today, I am so excited as the president and CEO of COSI to bring you one of our signature events. I can't even make up how good today is going to be. Today, I'm excited to talk to you about an incredible technology, but more important, the founder and CEO of this incredible technology, none other than Josh Gagel, the CEO and co-founder of Virgin Hyperloop, where he is leading a world-class team of engineers making Hyperloop a reality. Now, I know lots of you know what it is. For those of you who don't, trust me, we're going to walk you through an ABC to Z squared tour de force of all things Hyperloop. But really, this young man, I gotta go over his bio. He founded the company in 2014, and in a little over 2 years after that, they actually built the first scaled prototype to go at these incredible speeds, which we'll talk about in a bit. Today, Josh is leading the development of a paradigm-shifting electromagnetic, high-power autonomous technology bridging the engineering work with the passenger experience. I can't wait to unpack that technology. And really working on regulatory frameworks for this Hyperloop technology. And in November, that's right, just a few months ago, November 2020, Josh made world history, becoming the first passengers in the world to ride at incredible speeds on the Hyperloop. Previously, he was at SpaceX, developing the world's first reusable rockets, and led the successful testing of not 1, not 2, not 4, but 6 different rocket engines. I can't believe it. He's got to be 802 years old. This is an incredible legacy. Anyway, from the final frontier to the horizon right here on the ground, Josh shifted his focus to the power the Earth with revolutionary waste heat to power energy technology, leading research activities in ecogen power systems. There's so much to unpack. I know we're going to focus primarily on the Hyperloop, but in short, he got his undergrad from that famous school, Bachelor's in Science and Mechanical Engineering at Penn State, moved on to go to that other school some of you heard of to get his MS in engineering from Stanford University, where he was a graduate engineer fellow. Mr. Josh Gagel, a pleasure to have you on the COSI Annual Science Festival with us today.
Thanks so much for having me, Frederick. It's an honor to be here.
All right. Well, listen, I mean, we can talk for days about your background, but we want to get right into last November. We witnessed history with Pegasus and the Hyperloop. Can you tell us about what happened? Why was it so important? Break it down for us.
So we, as a company, as you mentioned, we started in late 2014, and our goal was to put passengers on a new form of transportation. But we were designing something from scratch. We weren't designing a plane or a car or a boat or a ship. We were designing something brand new. And whenever you're designing something new for passengers to ride, you have to show that it's safe. And I'll say the reason we get on planes is because usually we see people get off of planes. We like that they go fast, they're faster than a car, but we also get on them because they're safe. And so we had to show that this technology that was just an idea could be made safe for everyday people. And that was part of the challenge. Part of the fun is that, we had drawn up ideas for what the passenger experience would look like. We had drawn up ideas about what the technology would look like. But here we were, we had built it. We'd built a company, built an amazing team that put that together. And then Sarah, who is our director of passenger experience, and myself were the first 2 passengers in it. And the goal for us was to show that the environment, which we'll talk about the technology in a little bit, the environment inside of the tube is something that's actually quite like the Mars environment. There's very little air. It's almost like space. But you saw us in the test, we actually just had normal clothes on. And so we had to make that safe enough for not astronauts or thrill seekers, but for everyday people, because ultimately everyday people are going to be who rides it. And this was that first time in the whole world that people were actually going to ride a Hyperloop. So back like when the Wright brothers got on their Kitty Hawk plane, back when Chuck Yeager broke the sound barrier, this was the moment that Hyperloop was safe enough for humans to ride. And that's why it was so important and so excited.
Listen, that's really cool. And I'm really glad you brought up the Wright brothers, because when I was reading your bio and when I saw that famous video of you in the pod, I thought back to people like Louis Pasteur and scientists and engineers of back in the day, when they developed something, they tested it with themselves. Like most people who went in the space shuttle, they weren't building. We love John Glenn. John Glenn is amazing, but John Glenn didn't design the capsule. It's other people that design it, but you actually, as the designer, as the founder, were your own guinea pig, and I love that. Secondly, as a sidebar, I know you try to sneak it in there, but you kind of went to Mars because you talked about the interior of the pod was like a Mars-like atmosphere. So that as a sidebar is really cool. So look, you got the beautiful image up there. How did you get here? Walk us through how you go from concept of we don't want to do a plane, a train, an automobile, a boat. We want to change not just transportation, but mobility forever. Where did you start?
So we started with just an idea, and that to me is the reason I became an engineer. Like my mom and my dad are engineers, and that curiosity growing up, but the idea of you can predict the future from your chair, right? You have science, you have math, you have physics as your tool set, and you can predict the future. You could imagine something that people have never really imagined before, and then through that experience go and be able to create it. So the goal of what we wanted to do was to show that this could be safe, show that this could be comfortable, show this could be approachable. And Sarah, who's spent a lot of time on our passenger experience and getting people to want to get in a Hyperloop, we wanted to show that inviting atmosphere, show that experience of getting people onto something that they've never been before. Because the excitement for me was no one knew what a Hyperloop looked like until we showed them. Right? It could have looked like anything. And the power of the team, the power of the design is that we were able to build and create what it is we wanted that best solved the physics and best solved the math, but also made something that was beautiful and elegant and wanting people to get on. Because if it's not exciting to get on, people aren't going to be excited to ride it and ultimately have it be as transformative as we want it to be.
No, that's really cool, and we're going to dive into that in a little bit. But I know you glossed over it. I want you to unpack it a little bit more. I know you started off working out in your garage. Like, we hear so many cool stories. Bill Gates wrote the original code for DOS in his parents' garage. Mark Zuckerberg was writing the code for Face Smash, which later became Facebook, in his dormitory. You started off thinking about this kind of stuff, maybe not your exact pod now, but tinkering in your garage at home. Is this correct?
Yeah. And the part that I think was kind of interesting is, I learned to love to be an engineer when I was a teenager, working on cars in the garage with my dad. That's where he kind of inspired me, that I would always think he's the smartest guy in the world. How does he know how to do this? And he says, I don't. I'm an engineer. I learned how to do it because I know how to solve problems, and he would work his way through things. And so you take that ethos of why I became an engineer and you actually transplanted it to the starting and founding of this company, is that the garage is where ideas happen. The garage is where kind of curiosity happens. Mm-hmm. And that gives you the space. It's not like some stuffy place. It's a little bit gritty. It's got dirt in it. It's got a car in it, or it's got something else in it. And it's so that it's inspiration that you need to go say, I'm not going to build a train. I'm going to build something brand new that people have never experienced before. And where else better to do that than the place you learned how to become an engineer?
That is so great. I mean, we got people of all ages listening to this live stream right now. But for the younger folks thinking about careers and thinking about what you should study, regardless of what you want to do long term, things like science, technology, and especially engineering, they prepare you, as you heard Mr. Geigel say, to problem solve. And that can be applied to everything from, of course, engineering to medicine, to finance, to home building, to climate change, to you name it. So keep that in mind. We want to learn facts, but more importantly, how do you attack a problem, solve it towards a solution? All right. So with that, you talked about it just now. You said, you want to do something more than a train. A lot of times when people hear about Hyperloop, they think it's a train that's going really fast. Talk to us a bit more about what is the science, how does this work, and differentiate it from a train or a high-speed train that you might have in Japan or somewhere else.
Yeah. So what we wanted to do is create an experience that was actually all the best of the other modes and none of the worst. So, we've got lots of young kids on this show right now. And I'll ask you a question. Like, if I told you you could only watch your favorite TV show at 8 a.m. on a Sunday morning, you would think that that's a pretty crazy proposition in 2020, right? Or 2021. But yet that's how typical trains work. Like, you have to show up when they tell you to show up, not when you're ready to show up. So we want people to show up when they can or when they're available to. Because we have these small pods, they hold about, you and 27 of your friends. They go within 2 or 3 minutes of you showing up. And then they're going the speed of an aircraft inside of a tube, and you're going directly to your destination. So you're not stopping at every place along the way. You also don't have things that could basically cross the track, or you don't have to deal with weather or anything like that. And it's fully electric, it's fully autonomous, and then it's also able to use sustainable power. So we can go the speeds of an aircraft for a fraction of the energy emissions. So when we look at, my little 2.5-year-old, when he says, "Dad, what did you do when the Earth was heating up?" We could say we are building a technology solution that allowed us to go incredible speed, save you incredible time, and was good for the environment. And so the way that we do that is we have this tube and we take most of the air out of it. So we use these things called vacuum pumps, which basically suck the air out of something. And when we pull most of the air out of the tube, it would be like flying at about 200,000 feet. Think 5 times higher than a conventional aircraft. Or it's not all that different from like the surface of Mars. And so with that, you can go these speeds of an aircraft, but there's so little air, there's only a couple of molecules here and there, that you have very, very little drag. And so that's how you get this like tremendous amount of energy efficiency. And then as a testament to the team that we've got here, they've created new products, new magnetic levitation, new types of technologies that enable a battery-powered vehicle. So we have this idea of a smart vehicle and a dumb road, right? So any vehicle can just travel on the road. There's no moving parts. There's no switches, like cars on a highway. And so then our really exciting team, we developed a new form of magnetic levitation. So how does maglev work? So I've got my little 2-year-old's magnets here, and I'll try to show you here. So our system is pretty simple. What we do is we hang. And so here's one magnet. And if you've ever played with magnets before, a North Pole attracts to a South Pole, right? And so if they're too far away, though, what happens? The magnet falls down, right? And if I get too close, then it gets stuck to the ceiling, right? So the beauty of what we're trying to do is find that perfect balancing spot. And so as there's bumps here and there, we basically just react them out, and we can have a nice smooth ride for people. And that's how we get this levitation. So there's no bouncing, there's no turbulence, there's no jostling like a roller coaster or a train or anything like that. And then how we actually move forward is we do that same thing, we just happen to turn it this way. And so what it wants to do is it wants to attract, and we just keep pulling it forward and forward and forward. And it's the same type of principles there. And the team that we've developed, they invented this. So they're engineers too, and they created these out of, what started here. They drew it down on a piece of paper. They went through the designs. They went through a bunch of prediction and simulation, and then they built it, and it works.
Look, this is incredible, folks. You're listening to Mr. Josh Geigel, the founder of Virgin Hyperloop, this incredible technology that's taking mobility to the next level. This is on none other than COSI's 2021 Science Festival. This is incredible. So you went through that whole piece. I got to talk about some bits of them.
Please.
One, you talked about it's like a vacuum tube. So now you have a tube and you've sucked out all the air. Fine. Now you use this magnetic levitation and you figure out how to calculate. Like, are you guys creating algorithms, or how do you calculate so that, to your analogy with your son's cool magnet, how do you do the calculations to make sure you never get too close and stick, or you never get too fall off of the tube and kind of hit the bottom of if there is a bottom of the tube? Yeah. How does that happen from a technology standpoint?
So we have basically almost every type of engineer that's imaginable. We have electrical engineers, computer science majors, we have controls engineers. And so on those little things, we basically have something that detects, like a laser sensor, that detects how far we are away. And then basically what you need to do is you have to measure that. It goes into a lot of these algorithms and control things, control systems that we've developed. And then the computer basically makes decisions about how much do I want to push this. So if you imagined, kind of holding something in the air, if it starts to tip over one way, what do you have to do? Well, you have to compensate. You have to push it back the other way. And so the team that we've developed and the team that we have has developed solutions to be able to turn up or turn down those magnets, those electromagnets, to be able to stabilize the system. And they've demonstrated this. They have control. They can, I'll say, control this to within 1 or 2 credit cards, right? This that's the size of a bus, they can control that with a credit card or 2.
Wow. Well, that's phenomenal. Okay. So very cool. Now, I know you talked about the speeds. You're talking about aeronautic speeds you're talking about in a tube. Now, most of us, if we've had the privilege of going on a plane, have felt that plane taking off, and you're like, boom, you're pushed back in your seat, you're feeling it. I mean, you're doing this really quickly. What's the biology? Talk to us about the medicine. You mentioned it in your intro. You and your partner are there just chilling, regular clothes, no oxygen
Yeah.
tanks. How do you physiologically and medically make all this safe inside that tube at such excess speeds?
So we took a lot of existing things. So the one thing that I'll say engineering and STEM has done quite well is they document the work they do really well, and they put it into standards, they put it into papers, and they put that out there, they publish that out there so people can take those and make even better ideas from them. So a long time ago, they did a lot of studies about how to make, I'll say, safe conditions for humans in low pressure environments, right? And that's how the astronauts became able to do that. They had all those safety things. So we derived those, took those standards, the same things that they use for commercial aircraft, and adopted them into our design. And then for the actual feeling, what we wanted to do is we want this to not be a roller coaster. We want this to be something that people take every single day. Right. So to do that, you don't want to be jostled around. You don't want to be bumped around too much. You want to have a nice, smooth ride so you don't spill your apple juice or your cup of coffee or whatever it might be. And the goal for that is there's all of these standards that tell us how much acceleration you can feel. So the acceleration that we would feel is very much like you said, Frederick, like it's on a aircrafted acceleration on the runway. So you feel that push back into your seat, but then you don't have any turbulence or anything like that. And now all the side-to-side motions that you get, our system can react them out. But there's all these cool studies that show you what causes motion sickness. What are the things that make people feel nauseated? And so we've designed those out of our system and have our system meet these existing things because of all the good work that these other engineers and scientists have done. We can just take that and incorporate it into our design so that we can build things even faster.
Yeah. No, I love that. And that's another great message for everybody listening. And that's, as talented as you are not working in a vacuum like your tube, actually. You are working with so many other people, and such a good message. When we talk about the COSI Science Festival, we want people to understand that science is everywhere and for everyone. I mean, you can get into this, and, there are hundreds of different kinds of just engineers, I'm sure, that you're working with, let alone all these other STEM disciplines. So that's really cool. So look, you're in the pod, November, you crushed it, world record-setting speeds, first to do it on the planet. What is the future for Hyperloop? What does it look like? Because I got some questions. People are piling some questions on the chat. But before I get to those, what is this looking like for the future of Hyperloop?
So I had a very formative experience at the very beginning of this company. I met one of my friends' 8-year-old son at the time. He came in and was asking his dad a question. He said, "Dad, why do they call it roll down your windows?" And it made me pause for a second. He had never experienced rolling down your windows. All he's ever done is push a button. And now that I've got a 2.5-year-old, I want him to come to me and say, "Dad, how'd you get around before Hyperloop?" And the reason we want to do that is we want to build national networks. So the same way that, the Roman roads and the Spanish ships and the railroad and the airplane changed transportation, and the internet formed connectivity. As people get more connected, the faster we can connect them, the more ideas, the more opportunities that exist for people. And so we want to build national networks so that you can take things that normally take hours, you can do in minutes. Like imagine going from Washington, D.C. to New York faster than you could get across New York City.
Wow.
That's the kind of power. And then to do that, to give people these opportunities without destroying the planet around us, because I want my son, who's going to live till like the next century, he's going to be in the 22nd century. Like I want him to be able to enjoy the planet the way that him and I will enjoy it as he grows up. And so that's the responsibility that we have as engineers now that was different than like my parents' generation and the generation before, which was now we have a duty to the future to ensure that all the things we love about being on Earth are there for the next generation in the past. And that's the exciting challenge of being an engineer in 2021.
And I think that, what a great kind of concluding remark that not only are you at the cutting edge of technology, but today's ethos, yourself, your colleagues, and certainly the next generation of engineers and scientists are not only advancing these fields in incredible ways, but it's in our DNA to do it in a way that's healthy for the planet, far beyond your children, your grandchildren, etc. And that's really cool, and that's really special. And kudos to you at Virgin Hyperloop for leading that kind of example. So well done. I could ask you a million questions, but I want to respect my guests and pull some questions from the audience here. So one question is, can Hyperloop help solve global issues around the human condition? Well, you just talked about that, but unpack that more.
So what we see, and this is something that I've actually observed, and I kind of used this a little bit before, is that civilization moves forward as we move faster, right? The faster we're connected, the better it is. And we've seen the power of what the internet has done for, I was in like a remote village in Sri Lanka, and I was watching a young kid with YouTube up fixing his scooter in a single lit garage. And the question is, how are we doing that? How are we moving people? How are we connecting people? Because maybe a little bit of the downside of the internet is that it allows anonymous behavior to occur, which there's some good with that, but there's something harder about making sure you find that physical connection with the person and being able to, I'll say, work with them, find the solution as opposed to just like throw stones or cast doubt. And so the opportunities that Hyperloop can do is it can give people with harder access. So imagine growing up in an area that might be 4 hours from a big city, 4 hours from a good school, 4 hours from that opportunity. You're now able to do that in 20 minutes or in 30 minutes. Wow. And so now you have an opportunity to develop in a way that you just couldn't before. I couldn't go somewhere that was 4 hours away and come back and have dinner with my family every single night. And so now you've got these economic opportunities that just wouldn't be possible without something like Hyperloop.
Well, that is absolutely amazing. And the next question, this is a great one. So, can your technology help solve challenges with vertical transportation to space, such as, for example, an Earth to space elevator?
That's a good one. So directly speaking, I will say no, but there are some pretty interesting pieces. Our whole electric vehicle, we have an electric vehicle that's basically able to operate at 200,000 feet of altitude, which is kind of the edge of space, right? So all of the things that make operating electric vehicle in low pressure and the challenges, cooling and dealing with insulation and dealing with a bunch of other things, we've had to solve, we've had to learn, we had to develop a lot of redundancy and control for our system. So you could take a lot of those concepts and you could start to adapt them to other types of vehicles as you would go forward. So not directly a space elevator, but potentially the electronics that might be at the end, or a vehicle that might go up and down the elevator, but maybe not the actual like tether itself.
You got it. Okay, so Star Trek. I grew up being a fan of Star Trek. You may have liked that as well. One of the cool things about science fiction is how you see some of it come to reality. So in the Star Trek days, you had that looked like a microwave and some food came out. You also had the little touching on your chest, to communicate. Now we have cell phones. So, we haven't yet hit warp drive, although there are a few patents out there, but that's a whole other story, the warp drive. But, and it's probably not your technology, because as you just mentioned, the Earth to space kind of vertical elevator might be a stretch. But based on the iteration of technologies and the great minds like yourselves and other folks who are moving this stuff forward, do you see the Beam Me Up Scotty, the kind of, next millennial generation transportation after the great Josh Geigel and Virgin Hyperloop?
It would be certainly, I will say, if there was a teleporter that exists, I would probably take it. I think one of the fun questions I've had with my wife is that if you teleport, do you actually die or not? Like, is it like, are you reconstituted in the same way? Does it feel like you, or is that the end of you when you teleport, right? It's kind of that weird, like, philosophical question about it. But I think what I'm really excited about, what I see for, the transportation sector, you see a lot of electrification, you see a push for sustainability, you see a push for better user quality. But I also think there's opportunities, right? There's opportunities to do things that we've never really imagined before. And technology is moving at an incredible pace. When we started this company, we couldn't have put everything on the vehicle. And just a couple of years ago, were some of the individual components good enough for us to start putting on the vehicle? And that's the speed that things are evolving. And that's also the excitement of being an engineer, is that, I'm 36 now, and I don't know what 10 years from now is going to look like. I have some anticipation,
Mm-hmm.
But that's also really exciting, is that like, who knows exactly what it looks like, but if you're excited and you're curious and you know that you're going to learn and all these new things and incorporate them into what you do, like, I mean, sign me up every day of the week.
You got it. So you mentioned you were 36. Another question from the audience is, what were some of your STEM heroes, past and present? And I think that's, and I know your story, but share some of that, but also go broader, because along with everything else, this is about influencing the next generation to get excited about STEM. So what were some of your heroes, and what advice would you have to people who want to pursue this?
I think that the two I'd like to talk about are first the Wright brothers, and everybody talks about, the Wright brothers being the first to fly, and that's like incredibly genius. But I actually like a different part of the story about the Wright brothers, and it's about the curiosity. When the Wright brothers started to figure out they wanted to learn how to fly, what did they do? They didn't just start building wings and flapping. They realized that all the people who had learned how to fly, all they had done is climb up to something and then fall down. And they only had 1 or 2 seconds to learn how to fly. And how are you ever going to learn how to do anything well when you can only do it for 1 or 2 seconds? So their breakthrough was they wrote to the Smithsonian and they said, where are the highest sustained wind speeds in the United States? And Kitty Hawk happened to be the closest spot to Dayton. Right? And so then they went there, and in the first week or so, they got more flying time than like everybody before them. And so practice makes perfect. And that's the determination, the ingenuity that I really love about the Wright brothers story. And then the second one is actually, it's personal. I actually named my son. So my son's name is Lucas Maxwell. Maxwell after Maxwell's equations. Maxwell, basically the guy who codified electromagnetism. And there's a really good kind of blurb that talks about scientists' influence on the world after them. And Maxwell's has a very short one. It says, influence all subsequent physics. And to me, the profoundness of that statement, right? And then, my son's name is that Maxwell codified, the laws of electromagnetism, but light and the binary nature of light in some ways, right? The wave particle duality, that is almost at the antithesis of quantum, which goes against Maxwell's things in some ways. So that paradox is something that says, even if you think you know it, you might not know it at all. And so those two people, I think, are kind of embody the ingenuity, the spirit of being a good engineer, and the action associated with that. And the other is the creativity around doing something no one's ever done before, or identifying something no one's ever done before.
What an incredible answer. We only have 3 minutes left, getting close to the end. I'm going to take one more question from the audience. Before I get to that, so I got to ask, does Lucas Maxwell, I know he's only 2, but can he write the Maxwell equation of light? I know he can.
It's actually in his bedroom on a piece of paper.
You heard it here first on the COSI Science Festival. Yeah. Mr. Josh Gaggle and his wonderful son at 2 years old has Maxwell's equation of light up on his wall right outside the crib. No, that's great. One last question. This is actually a great question to round out this fantastic discussion. So thanks again for your time. What advice would you give to the youth who really want to be an engineer when they grow up and be the next founder of an amazing technology like you?
I think the number one thing I would say is curiosity. Is that if you're curious, there's nothing that's too intimidating. There's nothing that's too far outside of what your knowledge might be. If you're always curious, it makes you want to get better. It's kind of this pursuit of always becoming better, of finding your limits, of finding the edges. But really, it's also, if you're curious, you can never be bored. And that to me is a really kind of profound statement, is that you can always find, light and darkness, or you could fake. I'm in my music studio now. You can have, sound from silence. You can always find something. You can always be creative. And I think the thing that I would say, growing up with engineers, as parents as engineers, I had a different experience, but my wife didn't. And so if you have the opportunity to lend a hand to someone who might not have that experience, let somebody come in and observe, student, teacher, or whatever type of opportunity that might be, go out there and try. And if you can offer that services to somebody, do it. And if you're looking for that, see if you can find somebody who can help you do that, because they can be transformative experience, whether it's a teacher, whether it's an employer, whether it's a friend saying, this is what it could be like to be an engineer, a physicist, a mathematician. Like, do it. It's profoundly amazing. It's been the most rewarding thing that I could have ever possibly imagined, and I love it every single day.
Unbelievable. Ladies and gentlemen, you're listening to Mr. Josh Geigel, the founder and CEO of Virgin Hyperloop, which is revolutionizing transportation and mobility forever, just like the computer did, just like the telephone did, just like penicillin did. This is incredible. This is the 2021 COSI Science Festival. Mr. Geigel, I want to thank you so much for your time and generosity, and most importantly, your conviction to not only impacting humanity from a technological standpoint to move us forward, but to do it in a way that keeps our beautiful planet green and humming for generations to come. You know, and I love your point about curiosity. We talk at COSI, as I mentioned, science is everywhere and science is for everyone, but curiosity will set you free and allow you to reach all the heights and interests that you want in your life. Mr. Geigel, thank you so much for being with us. Just so your audience knows, COSI is a proud partner, STEM education partner with Virgin Hyperloop, taking their technology to everybody from the womb to the tomb. Thanks for joining us, Mr. Geigel. Thanks for all the listeners. Your questions were fantastic. We'll catch you next year at 2022. And in the meantime, do go through till Saturday, because tomorrow the Science Festival will be ending with a Guinness Book World Record breaking event. Not as fast and cool as Josh Geigel going 700 miles per hour in a tube, but really darn cool. Check it out tomorrow as we conclude our Science Festival at 5 p.m. Mr. Geigel, thanks so much. The final word is yours.
Thank you so much. I really appreciate what you're doing, Frederick, with everything that you're doing here and getting people excited about this, because we need more. I'm always looking for engineers, young, old, and everywhere in between. And from the womb to the tomb, that's me as an engineer. So I don't think you could have said it any better.
You got it. Well, thanks so much, sir. You have a great day. And folks, enjoy the rest of the Science Festival. Take care.